Okay, so that's important. We do that because what is the square root of 4? Oh yeah, zoom in. What is the square root of 4? It's 2. So 2 times root 6, we can write that instead as, instead of, you wouldn't write the times symbol, you can instead write it as 2 root 6. You don't need to write the time symbol. Okay. Oh, I should. 18. So we look at 18. 16 doesn't go into 18. 9 does. 9 times 2. So we break it into root 9 times root 2. And what is root 9? 3. So we can write that as 3. Instead of 3 times root 2, how else could you write that? 3 root 2. Now, if you're not sure, if you want to check your work, use your calculator. They should be the same decimals. So root 18, when you type it in your calculator, square root of 18, does that equal to 3 root 2? So typing both of those in, they should be equal to the same decimal, which they are, then we're good. Should I make that brighter? Well, I could turn down the lights if I have to. Can you see the calculator? Yeah? Okay. So same idea with division. If we have root 11 divided by 4, we can break that into root 11 times, or divided by root 4. And what is the square root of 4? 2. So root 11 divided by 2. Okay, so grab your calculators. I would like you to type in each one of these 3 into your calculator and write what to 5 decimal places what they approximately equal to. They won't be exactly equal to this because they're irrational numbers. So start with root 80. Square root of 80. Oh no, don't move. Was it 8 point something? So 5 decimal places? 94427. 2 root 20. Are you shocked by the outcome? So thrilling. Oh my gosh, they're the same. What if the last one's the same too? My mind's gonna be blown. Oh my goodness. Okay, so that tells me something. They're all equivalent. Yeah, they are all equivalent. Now, they are all the same, but one is the most simplified. Which one do you think is the most simplified form of the radical? 4 root 5. Okay, so the most simplified form, so I'm going to write this down, highlight it. So they're the same. I'll write that there. Okay, 4 root 5 is the most simplified because the radicand, what is the radicand? The number underneath the square root symbol, yeah, or underneath the radical. So the radicand is not divisible by a perfect square. A lot to write. Okay. The most simplified because the radicand is not, let me scroll up, divisible by a perfect square. So 80 was divisible by 4 and 16. 20, in the second example, is still divisible by, what perfect square will go into 20? 4. You could still break down 20 to root 4 times 5. Okay? So if it's 5, is that divisible by any perfect squares? No. So that's why it's fully simplified. root 80 and 2 root 20 could still be broken down into a product of two number where one's a perfect square. A product of two numbers. Okay, so they kind of show this here. Root 80, we could have done 4 times 20. Do we agree that 4 times 20 is 80? Yes, and what's the square root of 4? Which is 2 root 20. Okay, or 16 times 5 is also equal to 80. So root 16 times root 5, what's square root of 16? 4 root 5. Okay, so we always want to find the largest perfect square that is a factor. So 80 had two perfect squares that are factors, 4 and 16, but I think I did this exact example yesterday, 80 on the board. We want to choose the largest perfect square, okay? Root 80 is what we call an entire radical because the entire thing is underneath the radical. There is no coefficient. So that's an entire radical because everything's under the square root. Entirely under the root sign. Okay. Both 2 root 20 and 4 root 5 are examples of mixed radicals, but the most simplified one is 4 root 5. They're both mixed radicals, but one's the most simplified, and that would be 4 root 5. Okay, so our first half of this lesson is simplifying, so taking an entire radical, making it a simplified mixed radical, and then we're going to practice making mixed entires, which is so easy. We're going to do the tough stuff first. Okay. So more examples of entire and pure, or mixed, or entire and mixed radicals, kind of self-explanatory. All right, so let's look at this guy, 108. Let's simplify 108. So one method we could do is make a factor tree for 108. I think that's more time consuming. The method I like to do is to start dividing by perfect squares. And so that's where having this chart handy or knowing it by heart is going to make you faster. So you know you're going to start always, like you want to find which one when I divide it in will give me a whole number. Is it a factor? So you want to start numbers smaller than 108. And because we want the largest, that's why I'm going to work backwards. So I can reach the largest perfect square first. If I go this way, 4 might go into it, but so would 16 and 64, right? We want the largest one. So we're going to work backwards. Now, will 100 go into 108? No, at least to be at least half its size. Will 81? No. 64? You can maybe. Okay, let's check. Does it? No. Okay, then we try. What's next? 49. Nope. 36. Yay! Okay, so there it is. 36 times 3. 36 times 3. Or root 36 times root 3. And what is the square root of 36? 6. And so it's equal to 6 root 3. That's the process. I'm going to skip a few of these steps. Like realistically, you should be able to go from this step to this step. Right? Or we might even just go straight to this one and then so yeah, it gets repetitive after a while. And you'll see that. So let's do 50. Okay? So I'm going to go through this like step by step as if I know nothing about my times tables. So I take 50. I'm going to start dividing by perfect squares that are smaller. I can speak some days, but not today. All right, so first perfect square smaller than 50 is 49. Well, will 49 go in? Let's say I know nothing. I check. Oh, no. Then I try. I know 36. Now, if I know my times tables, I know that what's going to go into 50? 25. Ding, ding, ding. So what I'm going to do is I'm going to just write this as root 25 times root 2. I'm just going to write it like that. Root 25 times root 2. Same thing as writing it underneath one radical, right? It's equivalent. And what is the square root of 25? 5. How could I check my work? They have to be the same decimal. So the check would be to type in root 50. Where's my calculator? There you are. Get that decimal. 7.07, dot, dot, dot. Type in 5 root 2. It should be the same decimal. Oops. 5 root 2. And it is. Okay? That's how we check our work, if you're not sure. Now, if your scientific calculator does this for you, I will be checking that the day of the quiz and the unit exam to make sure that's not approved, right? You have to be able to do this yourself. No, boo. So if you don't have your graphing calculator, you might want to get it soon. Kennedy, can you write your name on the chalkboard? So if you're ever late for class, guys, I'm going to try something new because I always forget. Can you just like write your name on the board and then I'll remember and then I'll record it later? Yeah, I'm going to try that this semester. Anyways, this is being recorded, so let's just move on. Root 45. Thank you. So largest perfect square. Now, if I knew my times tables, I know right away what it is, but pretend I know nothing. First perfect square smaller than 45 is 36. So will 36 go in? We can check. Nope. Not. We want always a whole number. 25 is next. Nope. 16. Nope. And guess what's next? 9. Right? If you know your times tables, it's going to be really helpful. You can be really quick. So 9 times 5. Root 9 times root 5. And now what? What do you do? Square root the 9. That's why I always write the perfect square first, because that's the one we're pulling out. That's the one we're going to square root. And that equals 3. See, square root of 9 is 3, because 3 squared is 9. Easy peasy. 320. Okay. So 320. Start at 144. Does it go in? Nope. 121? Nope. 100 won't. I can just skip that. 81? No. And 64? Yes. 64 times 5. So we're going to write, how would I write it? Or root 4 times root 5. Square root of 64. 8 root 5. Okay? The more you practice, the easier it gets. You need to have this down because when you get into grade 11, 12, you're going to use radicals all the time. And you have to be able to simplify them like that. So this skill is so foundational for your 11 and 12 math, whether you do dash 1 or dash 2. Okay? All right, so what happens if there's already a number in front? Doesn't mean it's fully simplified. We have to still simplify it. Although it's already mixed, it's not fully simplified yet. Okay? That means there's a perfect square that will go into 192. So go ahead and find it. Start dividing. Work your way up until you'll find the perfect square that's a factor of 192. So we're going to write that as root 64 times root 3. Now remember, all the operations that are in between here. How do I remove my mouse? Go over here. No. Go away, mouse. Okay. So the operation that's in between each one of these is what? Multiplication. You can write that instead as 2 times root 64 times root 3. So when you square root 64, what's the square root of 64? 8. So we're left with 2 times 8 times root 3, or 2 times 8 is 16 root 3. Okay, so if there's already a number in front, whatever is being square rooted, that number that you get, the output of the square root, you need to multiply by the coefficient that's already there. Okay, so let's try another one. Find the largest perfect square that goes into 160. Might be obvious. You see it? Otherwise, work backwards. Grab your calculator, start dividing. Practice now, so when you get to your homework, you know how to do it yourself. And you can watch me and it looks easy. You have to be able to do it yourself. So grab your calculator, start dividing. This is one of those units, and knowing your times tables makes you superior and faster. Like any unit really in math, but especially in this one. 10, so we have 3/4 multiplied by root 16 times root 10. And what is the square root of 16? 4. So 3/4 times 4. What is 3/4 times 4? Yeah. Is that surprising? Why is that not surprising that it's equal to 3? Because you're super smart. Okay. That, and if you multiply 3/4 by 4, okay, 4 as a fraction is 4 over what? 1. And so what happens is when you have, with multiplication and division in BEDMAS, they can be interchangeable. So you can go 3 divided by 4 times 4, or we can actually reduce these 4's out. One's on the numerator, one's on the denominator. They're going to divide or reduce to 1, and that's why we're left with 3. Okay, so just by looking at that, I can see that's going to equal 3. So one's on the numerator, one's on the denominator. So 3 root. Okay, let's move this one. Okay, what are we going to do with C? Divide. So root, and we're going to have 2 separate radicals. So root 7 over root 9, which equals, no, we don't want decimals. Silly. Which one can we simplify? The 9. Root 9 is 3. So we do not want decimals. In a rare occurrence, I might ask for a decimal, but I probably won't. From now on, we leave things as radicals because that's an exact value. That's the proper way in high school mathematics. We don't like decimals that are approximate. We like exact values because if you keep it approximating your decimals over and over and then you start combining them together, there's error in your work and in your answer. So you keep rounding, right? And you'll notice that in science as well, especially. We don't want error, especially if you're like building a bridge. Okay, but you're not building a bridge, but it's the same thing. Okay, so how do we go the other way? How do we convert from a mixed radical to entire? It's the easiest thing in the world. It doesn't require your knowledge, well, actually maybe it does require your knowledge of your perfect squares, but way more minorly. So all we have to do is we have to bring 3, we have to turn 3 into a radical. We have to bring it inside a square root. So how do I do that? I'm going to square it. What is 3 squared? 9. Would you agree that 3 and root 9 are equivalent to each other? So I just square it to bring it inside, and then I multiply it by 14. 9 times 14, excuse me, is 90 plus 36 and 26. Tell me if I'm wrong, okay? Because that happens. Good? I did 90 times 10 and 90 times 4 and then added them together. It's the easier way. Okay? So 2 root 5, to bring it inside the square root, what do I have to do with the 2? 2 squared, which is 4 times 5. We just have to square the number to bring it underneath the square root. What is 4 times 5? 20. Okay, so why would we do this? Why do we change things into an entire radical? There's only one case. Okay? The reason why we would do this is usually for ordering purposes. We want to order things. So what I mean by that is if I had 2 root 3 and I had 3 root 2 and I said which one's larger? Just by looking at that, can you tell? Probably not, right? But if we turn these into entire radicals, 4 times 3, 9 times 2, can you see now who is larger? Yeah, obviously 3 root 2 is the larger one. And so you're going to be expected to convert things into entire radicals so then you can put them in order from least to smallest. That's going to be a question on your quiz. I'm telling you now. There you go. There's a question, written response. Done. Okay, so you have to be able to show, part of your mark is showing me you're converting it to entire radical, and then another mark for actually arranging it. In junior high, part of the curriculum was that you could type it in a calculator and then order them, right? No longer in high school. In high school, the curriculum says that you must convert it, show the conversion to an entire radical, and then order. So no more typing it in your calculator to arrange them. You can check your work that way, of course. But, all right, so that was a spiel. To bring 4 inside, what am I going to do with it? Square it. So what is 4 squared? 16 times 7. 112. Okay. So to bring 10 inside, square it. So we're squaring the 10 and then multiplying it by 6. So 100 times 6. 600. Okay. So we're not simplifying here. We're just writing them as entire radicals. Simplifying is always writing it as a mixed radical. Got it? Okay. All right, how do I bring 3 over 2 inside? Square it. Okay. So 3 over 2 squared. Put that in your calculator. Now, you have to put it in brackets. If you type in 3 over 2 squared, that mass is going to just square the 2. So you need to actually type in 3 over 2, or 1.5, squared in brackets. Okay? Now, I'd like that as a fraction. How do I change that to a fraction? Math. Enter. Enter. 9 over 4. Is that shocking to you? Okay, when we square, you know you have done exponent laws. I know you have. Otherwise, you shouldn't be here. Because that was in your curriculum, right? In junior high. 3 squared is 9. 2 squared is 4. 9 over 4. Multiply that by 8. So notice how I'm never typing in the square root symbol. We're just simplifying what's inside the radical. So I don't actually type in the square root. I'm just typing in 9 over 4 times 8. Simplifying what's underneath the radical. 8, which makes sense. 8 divided by 4 is 2, and 2 times 9 is 18. So if your question is a fraction, you should work with fractions. If your question's a decimal, then you can work with decimals. Okay? So to bring 0.4 inside, what are we going to do to 0.4? Square it, and then times it by 50. What is 0.4 squared? 4 times 4 is 16. So 0.16? Right? Yes? I don't think so, because you're going to have 0.4 times 0.4, so that's 2 decimal places. So when you move 2 decimal places, I could be wrong. Let's see. Pretty sure. Yeah. 0.16 times 50. 8, root 8. Okay, and the very last one, can you bring the negative inside? No, so only the 5 can be brought inside. We're going to leave the negative on the outside. Okay, and square the 5. What's 5 squared? 25 times 7 if you have 5 quarters, or 7 quarters. 7 quarters. How much money do you have? $1 million. You better stay in math class. You're going to be disappointed with your quarters. Group 175, right? Yeah. Guess myself. All right. We're doing good. So here's an example, okay? This is a great test type question. It says, without using a calculator, that means convert it. I don't want to see your decimals. Keep those decimals away. Those are private. I don't want to see them. Arrange the following mixed radicals in order from greatest to least. So we're going to first convert each one of these. I would like you to try this, and then we'll go over it, okay? Convert each one of them into an entire radical. Convert them all into a entire. What we're just doing, bring the 3 in by squaring it, timesing it by 5. Okay, convert each one. Give it a shot. So which one's going to be the greatest? 8 root 2. Done. Okay, because we can see it's root 128. Next largest. The 75, so 5 root 3. 3 root 5. 2 root 8. And last, root 15. So there's your answer. Okay? Yeah, you would leave root 15 as root 15. That's how it was originally given to you. And it can be simplified. But even so, you'd answer it in the original form. Okay, so let's talk about Pythagorean theorem, everyone's favorite thing. With Pythagorean theorem, in the past, you'd often get decimals as answers. So what if we want to leave it as an exact value? So this example says, use Pythagorean theorem to determine the exact length of AB. Okay? Express your answer in simplest mixed radical form and then also as a decimal. So first, in order to find AB, what side do we have to find first? AD. Yeah, this side. I'm going to call it, it doesn't matter what we call it. Yeah, I was going to say Y, but we can also just call it AD. Doesn't matter. So because we know, I'm going to call it Y. Do we know our hypotenuse? Which one's the hypotenuse? The longest side, so in this case it's 12. So there's a few ways you can set it up. So 12 squared equals y squared plus 8 squared. Or some of you might already go straight to 12 squared minus 8 squared, right? Your hypotenuse minus the other side equals y. Okay, so what is 12 squared? 144. What is 8 squared? 64. We want y by itself. Next step. Subtract the 64, bring it over. I believe that's 80. Right? No? Yes? Yes. 80 equals y squared. And then what do we do to both sides? Square root. Now, I'm going to leave this as root 80. Because I do not want decimals. I want to answer with the exact values. Okay? We are not going to square root the 80. I'm actually not even going to simplify it. Because that's not the one we need to simplify. The final answer is the one I want to simplify. So root 80 is fine. It's an exact value. If I put that in my calculator, give me a decimal. I don't want the decimal. So now we can solve for x using Pythagorean. X squared equals, because that's your hypotenuse, 6 squared plus, what is y? It's not 80, root 80 squared. So here's a really cool thing. What happens when you square root 80? It's not a decimal. Plug it in your calculator. What's root 80 squared? Plug it in. They cancel each other out. Is a square root and a square not the opposite operations? They cancel each other out. It's just 80, and that's why I kept it as root 80. So when I square it later on, it's just, we want the exact value. We don't want the decimal. See, if you rounded root 80 before to some decimal, and then you squared that decimal that was rounded, it's going to give you 79 point something, something, something. But really, your y squared is equal to 80. 80 plus 36. And now, square root. So let's simplify root 116. So what I want you to do is find the largest perfect square, which is our AB side. Find the largest perfect square that goes into 116. So start dividing. Find the largest one. So this is the, simplifying stuff. Okay, 100 won't logically. 81 won't logically. So if you know your times tables, you can kind of get a better idea. Try 64. 36. 25 won't. 16. Anything go in? Oh, that's it. 4 times 29. 29's prime, so we know that's as low as it goes. So root 4 times root 29, or square root of 4 is 2.